people. For those of you that don't know me, my name is Ivan. I work at Big Fish Software, where I'm the sole developer and owner and proprietor and many other things. And one of the organizers of WebCamp and this meetup as well. I'm really happy to see you in such a large number. And I'll be talking about generators. Generators are a new addition to PHP 5.6. Before generators, there were iterators, so I'll just start with iterators. How many of you know about iterators? How many of you have used iterators? So, ish, some people. So I'll just do a brief overview of iterators so you get up to speed. Iterators are basically objects which can be iterated. That means you can put them in a for each, and you can go over them value by value, and they will yield some values for you, and you can use them. Like an array is also iterable, but iterators are objects which implement similar behavior. There is an interface in PHP called iterator, which you have to implement if you want to make an iterator. So basically any object which implements this interface, these 5 methods, can then be used in a for each loop later. And the 5 methods are so current, which returns the current element, key, which returns the current key. That means since you like an array, you have a key and a value for each element. You have next, which goes to the next element of the iteration. You have your rewind, which resets the iterator to the beginning, and you have valid, which basically says if there are any more elements to iterate on, true or false. So let's start with the use case. You want to read a file, you want to read it line by line, and you want to do something with each line. It doesn't matter what. So the standard approach here would be you get a file, you open it using the file method, which returns the whole file line by line as an array. Okay? Then you iterate over it and you do something with it. You have a function. This is great. This usually works, but the problem starts when you have really large files you want to iterate. And then you might have problems with your memory. Yeah? The good thing about this approach is that especially when building larger systems, you want to separate your logic for reading from file from your logic which processes lines, okay? And in this method you can do that. You can actually put the method which reads from the file in one function, and you can put the processing in another function. And this is really useful if you want to have a properly architected system. Solid principles. The first one is single responsibility, and that's each of your components should only have one responsibility. So it's not a good idea to have one component with both is concerned with reading from a data source and processing the data from it. The bad thing about this, it's a total memory hog. It can, if for larger files you just can't use it. If you have a 1 gigabyte file, it will probably take a long time to load it in the memory, not very efficient. It will use up a lot of your memory and so on. So the solution to this problem, to the memory problem, is to iterate. So you open a file and you use the file open, and then you iterate calling fgets, which reads a line in a while loop, and for each line you process it. In the end you close the file. So this is a really simple solution. It solves your problem of having a memory problem, because one by one line is read from the file, and you don't overload your memory. You only have one line loaded at any time. The problem with this is that it violates the single responsibility principle. You cannot separate your reading logic from your processing logic. They are totally intertwined in this example, which is not a really good thing. So the solution to both of these problems is use an iterator. You can create a class which will read from your file and yield you line by line as an iterator. It will look something like this. I'll go over the bits in a minute. Okay, so first the class needs to have a state, so you have some protected methods in there. You have your file pointer, which you have to store once you open the file. You have the current line and the current line number, which are the things you want to yield. So when you construct an iterator, you give it a path to your file, and then you open that file and store the pointer in FP. When in the destructor, when the iterator is destroyed, you just close the file. Okay. You have your next method, which means that which will read the next line and store it in memory and increase the line number by 1. Simple enough. You have rewind, which will seek to the beginning of the file, reset to the first line, set the line number to 1. Actually, this should be 1. Okay, it's a bug. And you have valid, which basically checks if your current line is not false actually, which is what gets returned if there is no more lines to be read from the file. And then you have your current and key, which return your line and the line number. Yes. And this is how you use it. You basically instantiate the iterator and you put it in a for each loop, and it's exactly the same as the first example. Yeah? You can separate your logic again, so you can have one function which constructs the iterator, and you have the other which does the processing. And basically, if any time in the future you want to separate your reading logic from you want to, let's say, read from a database or an API or whatever, you can substitute that just by overriding one method, not overriding everything. Of course, this iterator, I would never use it because you shouldn't reinvent the wheel. There is already a thing for that. It's called SPL file info and SPL file object, which will allow you to do the exact same thing, but it's included in PHP core, so you don't have to do anything. I would really recommend everybody have a look at the SPL, which is the standard PHP library. There is a page in the PHP manual which shows you loads of iterators which are included in there. You can iterate all sorts of things. So I'm not going into details now because we want to focus on generators. So iterators are cool, but there's a lot of code. You've seen that class. It takes a long time to write it. It's tedious. I've never really used iterators much, except in some cases because they've been such a pain to implement often. And this is what generators basically solve. Okay, generators are just syntactic sugar for making iterators. So they make iterators easy, nothing else. So here's a really trivial and stupid example. So generators are functions which don't have a return, but have a yield, one or more yield expressions inside. You can just think of them as functions which return more than one value. And this is simple. This function returns 3 values, 1, 2, and 3. And what happens when you run this function called generator, when you run it, so here, you will get an object of the class generator. You will not get a return value from here. You will get an object which can be iterated on. And this is all done in PHP core. You don't have to think about it. As soon as you have yield in your function, the return, what you get when you run this function will be the generator, and you can put it in a for each loop. You can iterate upon it. So in this stupid example, when we iterate over this generator, what will happen is that for each loop of this iteration, the generator will execute one line of this, the code up to the first yield statement. Then when the other loop comes around, it will go to the second yield statement. When the third loop goes, it will go to the third yield statement. That means it's lazy evaluation. It will not evaluate the whole thing at once, but it will do it as you iterate. It will go through these yield statements. And if you have more code in between here, it will just execute all the code up to the next yield statement. We'll see in the next. So when you run this, you get 1, 2, 3. It's pretty simple. Yeah. Interesting thing that you can also have a return statement in generators, but this will abort the execution after the second yield. It will not yield 3. Okay. But if you put a value in your return, that will fail with a fatal error because it makes no sense in this context to have a return a value because it makes no sense for a generator. So this is how you would solve the reading lines from a file. You open the file, you iterate line by line, and you yield each line. In the end, you close. So what will happen when we start iterating over this generator? first time, for the first loop, it will execute all the lines up to the first yield statement and yield it. So it means first loop, it will open the file and it will yield the first line into your for loop. And so as it goes for each cycle, it will yield the line until it finishes, it will close, and it's done. And this is the whole code you need to replace. This has the exact same functionality as the iterator I showed you a bit earlier with, you know, the bunch of code. This is it. Okay, there is no error handling here, but there was none in the iterator either. So this is much, much simpler to do. There is another thing you can do. I have not explicitly yielded the key here, but you can do that as well. If you have a syntax yield number, this little arrow, then line, it will actually, you can set what the key will be in your iteration. So if you know, when you do a for each, you can also use the key and the value for each iteration. Okay, the usage is absolutely the same as it was for the iterator, because the generator is an iterator, nothing more. So that's important to understand. The generators are basically just a cool way to make iterators, and they make it the main advantage. The practically only advantage is that it's super simple to do. You can, you know, this you can write in, you know, it's 5 lines of code. It's really simple. Okay. They are also faster than iterators by some tests. I have not done many, but there's a test here by Nikita Popov that shows that for this trivial example, like relating from a file, they can be up to twice as fast. I suppose because there is no overhead of keeping state and calling next and valid all the time. It's all handled internally, so I suppose that's why I get a little boost of performance there. They are really trivial to mock. If you do unit testing, you know, want to mock them, it's just you just pass a callback which does something or nothing. That's it. They have some disadvantages as well. Generators, unlike iterators, can only be traversed once. So that means that once you start iteration, once you start a for loop, you cannot rewind it to the beginning anymore. This is usually not used much anyway, so this is not usually something that matters, but it needs to be noted. The second thing is they cannot be serialized, so if you cannot save your state to disk somewhere and continue later on, this will not work. You cannot index them, which means that you cannot, like an array, if you have an array, you can take the third element from an array. You cannot take the third element from an iterator or a generator, basically because you have to iterate the 3 previous elements to get to the 4th one. You need to use a loop. Okay, and you cannot use some array function such as an array map, array filter, but there are alternatives to that. I'll come to that later. So this is the very basic bit about generators. Are there any questions now? Do you understand, you know, what's going on? Anything not clear? No?
I just have one question. If you could just rewind to the slide where the generator was declared, this one. Does this mean that it will open the file on each iteration?
No. It basically what means that when you iterate over it, it will execute parts of this function and it will pause on yield. So this function, through the whole iteration process, will be executed exactly once, from the beginning to the end. But it will not be executed at once. It will be executed for each loop. It will go to the next yield statement. So basically just when you first start iterating, let's say, you know, how for an iterator you have a next method which goes to the next. So if you don't want to use a for loop or a for each, you can call next on an iterator, okay? So in this example, first time you call next, it will start executing and it will get to the first yield. It will return, you'll have the first line as the current element, okay? And it will pause there. Next time you call next, it will just resume from the place it stopped. It will do one loop, and it will make the second line available as the current element of the iterator. And it goes like that until there are no more lines, and the method exits, and your for loop or your next will not. Actually, if you remember the valid method from the iterator, will return false in that state. That okay? Good. So I have an actual example, which this is something which happened to me about a month ago. I work on a phone book, Yellow Pages, which has an API, a JSON API. And what happened is there is one endpoint which returns a list of all categories in the phone book, things like plumbers and tailors and so on, computer shops, whatever. But it returns the whole list because some vendors need this to synchronize their categories with our categories. So this is usually about 1,000, 2,000 categories, which is not a problem if you do it all in memory like I showed. But it happened that there was some person who imported the Mexico data, seems to have messed up and imported 36,000 categories, which are mostly nonsense. And what was happening that we were having out-of-memory exceptions because every PHP process was limited to a certain amount of memory, and it just went over it when you tried to do the whole thing in memory for the categories. So this was this is a really simplified example of our process up until now. We would load some data, we would run JSON encode on it, and we would return it to the user, okay? And this started to do, this is the problem that first you have all the data in data, then you have again all the data in the JSON when you encode it, you have it twice in memory, and then you echo it. So that's a lot of wasted memory. So what we decided to do, I was already in love with generators. I said, yeah, we'll use generators. Finally, a good use case for generators, really. So what I decided to do was use nested generators, okay? This sounds a little tricky, but it's really simple, okay? We have 3 generators. We have first generator, which does an SQL query, iterates over the rows, and yields row by row from the database. This is the database data as it is, just select star from branch. This is the German for category. And I coded this, then I realized that this PDO statement, I don't know how familiar are you with the PDO, but the PDO statement you get when you run this prepare and then execute, this is actually already an iterator. So this is, I was iterating over an iterator, which is not really needed. So you can just replace this and actually return the statement. It's no longer a generator, but it's basically the same thing. You get an iterator which yields row by row of data. And the kind of data you get from it, each row will look something like this. It's just a bunch of columns with a bunch of data on a badly constructed database, because you can see it uses underscores, then camel case, then... Okay. So you have one iterator which returns you the data as it is in the database. So you have a second iterator which takes the first iterator or generator as the argument here, iterates over it, and actually yields the model as you'd like to return it to the client. This is what you want in the API, just the data, okay? So for each row in the database, which is this, yield a simpler model. We just have the ID, the name, and the slug, which map to these 3 columns in the database. So this will just return the models. So each iteration of this generator will return the model as you want it in the end, the API, as an array. Okay. So it will look something like this. Each row will look like this. And this is a great category, I love it. And you have the third generator, generateception, which will return JSON, parts of JSON. If you can see, so first thing, this generator takes the previous one as an argument. The previous one will return values like these for each iteration. So first thing, we want to yield an open bracket because that's the start of a JSON array. You want the output to be an array. We iterate over the models here, and we just yield them encoded, okay? So for each of these models, we run JSON encode and yield it. So you will get a little string, which is your encoded model. And all this CRUD with the first and so on is just so that for each iteration after the first one, I want to put a comma. I want to yield a comma here because my models must be comma separated. So that's just CRUD because of that. And finally, you would yield a closing bracket. So let's see, if you had some 3 models, this, once constructed the whole thing, it will yield first an open bracket, then the first model, then a comma, then the second model, then the comma, third model, closing bracket. And I mean, how many models there are? This is how many fit on this slide. And this is basically your whole usage. Okay, this is how you would use it. You could put this in a PHP file and it will yield the JSON you want. This is quite an important line, okay? If you're using PDO, there is an in MySQL, there is an option called MySQL use buffered query, which is enabled by default. And if enabled, when you query the database, it will actually load the whole result into the memory. Even though you iterate over it row by row later, it will load everything, preload everything, buffer it into the memory. So you want to disable that for really large data sets, because otherwise you'll always have memory problems. When this is disabled, the PDO will actually ask the database for each separate row as it iterates over the first generator, okay? So you will have only one database row in memory at any time. Okay, so now this, you run the methods I showed you earlier. You create the first generator, which takes the database connection as the argument. The second one takes the first generator as the argument. The third one takes the second generator from the argument. So again, the first one yields data from the database. The second converts the database data to the model, to your domain model. And the third one will actually yield chunks of JSON. Then you iterate over the third one. What will happen? The third one will iterate over the second one will iterate over the first one, and you will actually get a cascade of things happening. So for each iteration, they will fetch one row from the database, convert it to your model, JSON encode it, and yield it as chunks of JSON. And that way you can actually do the whole thing with using like 500K of memory instead of, I don't know, I believe it was something in the region of 100 megabytes or 80 megabytes, which we used for the Mexico data. And we had a memory constraint on 32 or something like that. A more realistic example is if you use something like Symfony. Symfony has a prepared kind of response for it, because your controller has to return a response object, and you have something called a streamed response, which basically takes a callback, which is this exact code you saw on the last slide. So this is if you're using anything Symfony based, this is your solution, or if you're using something else, there is usually an equivalent. You can have a look. Okay, so that's this is the most complicated part of the whole lecture. Okay, so I don't know if anybody has any questions at this moment. Anything that's not clear? No? Excellent. Okay, so there are some other examples I have. There is a mathematic example, which is using infinite series. Well, infinite-ish, because you can't really do infinity on a computer, but this is something that usually comes up when you're doing some math, and not otherwise, but I came across a couple of problems from tests for employment or such, which would like something like this. So I'll just go to the most basic example, which is the range function. The range function returns an array of integers from a minimum to a maximum number in steps of, by default, 1, but you can override it. Okay. The suboptimal approach to doing this is if you want a really big range, this will make a range from 0 to 1 million. Okay. It's not that big, it's big-ish. And you want to do something with each number. This is nowhere close to infinity, okay? This uses 70 megabytes of memory. I don't even. The good thing is that in PHP 7, which I have installed 2 days ago, this only uses 21 megabytes of memory. And the reason for that is they actually rewrote the way values are stored. For primitive values such as floats and integers, the memory, the amount of memory saved is about threefold, because they don't save the whole structure as they do for objects and such. They do it simpler, but let's not go into the PHP 7 is really cool. Okay, so what can we do to save memory here? You can make an iterator and do all this. Yes, it's simplish, but nobody wants to write that, So you can do a generator. That's it. It's 3 lines of code. You have a for loop from minimum to maximum, increase by step, and yield a number. And that will actually return a generator which returns a range. So when you iterate over it, you get the same thing as you would if you iterated over this range here. However, this one goes up to max value for an integer, okay? Which is a bit closer to infinity, but not much. If you really want to go close to infinity, you need to use what's called one of the extensions which offer arbitrary precision number mathematics. I chose BC Math. It's basically it provides some functions which do things like comparison and addition, and they use strings instead of integers, so they can store extremely large numbers. This can go, I tried it out on a Google, which is Google with an O, which is 10 to the power of 100, and it didn't blink an eye, so this is pretty nice. It's basically limited to your memory, and you won't reach that anytime soon. Okay, that was the second example I had. There's a couple of things, the PHP has a number of methods which help you work with iterators, and as such with generators, but it's not very rich about it. Actually, there are 3 of them, okay? Because you cannot use your array functions, things like array walk and array map, array filter, and so on. You can use iterator apply, which will basically run a given function on each value yielded by your generator or iterator, that you can give it a function, this is my generator which goes from 1 to 100, and do iterator apply. This is a really horrible way to do it because I think it's really convoluted. You need to return true here, otherwise it will stop your iteration. Then you need to give this generator back as an argument, so you would receive it back here, and it's complicated. It's a bit ugly. I've never used this function, I must admit. Okay, there's iterator count, which will basically run through the whole of your iterator. It will iterate through the whole thing, and it will count how many elements there are in there. Useful-ish, I suppose, maybe. Iterator to array. This is actually useful. This will convert your iterator to an array. It will execute the for each loop, and it will just build an array out of it and return it. This is good for debugging, because when you var dump an iterator, you will just get class generator and or iterator, whatever you're using, so you won't know what's happening. So I'm not very impressed with these functions, but there is a really good alternative to it. Nikita Popov, who is one of the core contributors to PHP, wrote ITER project, which is iteration primitives using generators, which is basically a set of utility functions, which will be very familiar to anybody who's done any functional programming, which do things with generator lazily. They have a range function. It's better than mine. Let's say if you give it 5 then 0, it will return from 5 to 0 backwards. It will not run infinitely. It works with floats. You can give it a step of 0.5 and so on. By the way, this syntax here, see, use function, this is also new to 5.6. Up until that, you couldn't import just a function from a namespace. You could only import classes, and this will just take a function from iter called range, and you can just use it as range here. It will override the default range function of PHP in this example. If you have all the versions of PHP, you can still use it. You will just have to write iter range everywhere instead of just range. It's okay. Second, take. Now I love this example, because here you have a range from 0 to, let's call it infinity. And you means take first 5 elements from this range. So this is a generator, okay? Range function returns a generator. Generators are lazily evaluated, which means it will not build a whole array of 2 billion and I don't know how many integers, it will only, when this function take iterates over this generator, which it does internally, it will do so 5 times. Actually, I have a bug here. It will only return to 4, okay? It will return the first 5 elements. I've put 6 here. And this will take up almost no memory as well. Even if you have a, let's call it an infinite series here, which I thought was really cool. Okay, so you have mapping. I forgot. So another advantage of all these functions is that they can take arrays as well as arguments. So you can either put in arrays or iterators, generators. So unlike array walk and iterator apply, which only work on arrays or only on iterators, this actually works on both, which is kind of cool. Map takes an operation as the first argument and some input, either an array or an iterator as the second. And for each element in this array, it will apply this operator. So here, this is basically any callback. But one of the functions, this operator which comes with iter, this will return a function which will take the input and multiply it by 2 in this case. You can have anything here, so division, addition, power, I don't know, there is a list of, and this is second. So this will basically map over this array here and multiply each element by 2, and you will get 2, 4, 6, 8, 10. Okay? This is very typical of functional programming. They use mapping a lot and filtering, which is the function filter takes an operator again and an input, and this will filter all the elements from this array which are smaller than 0, because we have less than 0 as this operator. And you can this is usually used in combination. You can filter, then map, then in the end you reduce. Map-reduce algorithms are quite well known and so on. Reduce will basically take everything from this and apply this operator to them. So it will take a range from 1 to 5 and it will add it. You will get 15, I think. The last argument here is basically, this is also very typical for functional programming. This is called fold in Haskell and other things. It actually adds 1 plus 2 plus 3 plus 4 plus 5, and you have to have a final one, 0, which for addition you have 0, for multiplication you have 1, because in addition, adding 0 does nothing, and in multiplication, multiplying by 1 does nothing. So this is your identity thing here, okay? Or you could have some remainder here, whatever, you know. So when you combine all these things, you can get some really cool things from done really in very little code, okay? I will just show you one more function. I really like this one, and I really like it because I actually contributed it to the project, so I'm kind of proud of it. And this is called reindex. It takes an input and it takes an operation. This function index will take this will return a function which takes an element from here and takes the ID from it, okay? So if you run a function you get from this one, if you run it on the first element, you will get 10. If you run it on the second, you will get 27 and 39. In effect, what this does, it will change the keys of your array to the value which is under the ID for each element, okay? And there is something similar for if you have objects here, or you can write your own function. It's, you know, this is something I always needed, because I would need to store something indexed by the ID so I can have a map, so I can easily find it later, okay? So what I would usually do, I would take this and I would probably run, I would convert it to an array and store it somewhere, and I would have a lookup map for these people here, so I can look them up quickly over by the ID. And okay, that's it from me. Any questions about the last part now?
I assume the parameter the index function can be any other of the keys inside that array.
Yes, so you could have name, or you could have anything else you have here. You could have your custom thing here. It's really simple. So if this was an array of objects, there is a function which returns values of properties from objects. I think it's called property. And so on. I mean, this is basically limited by our imagination. This is just a few examples. There's loads of functions which are still there. It's a really small project. It practically has no documentation, but the code, it has, I think, 3 files. Everything is documented with examples in the doc blocks. It's really simple to use. And I really encourage you to have a look. It saved a lot of time for some things for me, and everything is lazily evaluated, which is really good. You can start doing something like this on all the rows from your database. Let's say the first generator in the complicated example, which yields rows. You could have that as input and have this as ID, and then when you iterate over the resulting thing, you could have for each ID object, go over it, and have it lazily evaluated and fetched from the database as you go. And stop when you want it, not worry too much about your memory and so on.